Hey everyone, welcome to this video on finding the area between two functions. So this is a skill that we have learnt in maths methods and we're just going to apply here but using the sum of the spec integration techniques. So the question says find the exact area, so that's going to mean it wants us to find an answer in terms of pi or e or ln. It means we're going to need to process the fundamental theorem of calculus exactly between these two functions, x plus cos x take 1 and x cos x over this given interval. So I've graphed the function and I've already gone ahead and g-solved the area between them, 13.496. So when I get my final answer right, I can put that in my calculator and make sure they're the same. And that's going to tell me, yes, your answer is exact and it is correct. So here we can see the blue function. All right, the blue function is the one I put in first, is x plus cos x take 1. So that's going to be our top function. And we know it's the integral of the top function take the bottom function, and we're integrating from 1 to 2 pi. So let's go ahead and perform this integral. We're going to be doing the integral from 1 to 2 pi of the top function, x plus cos x take 1. And then we're going to take away the bottom function, which is x cos x, with regards to x. Okay, so that's the integral that we're performing there. Now, all three of these components are very easy to integrate. In fact, we might jump to the first step of the fundamental theorem of calculus here. And the integral of x is going to be x squared on 2. The integral of cos x is going to be sine of x. And the integral of 1 is going to be x. And then I'm going to put this take here. And for the integral of x cos x, we're going to have to work that out separately. We have to use integration by parts. So if we have the integral of x cos x, all right, we're using integration by parts. So we want to define these features of it. So I'm going to define u as x, so that will make u dash 1. And if v dash is cos of x, then v is going to be sine of x. And using integration by parts, it says the integral of x cos x will be uv, which is x sine x, take the integral of u dash v. All right. Now the integral of sine of x is negative cos x, so it becomes x sine x take negative cos x. It becomes x sine of x plus cos x. Okay, so really that's the only addition to what we would do in methods. We just add on some more spec differentiate integration processes. So that means this component of it, when we integrate it, this is what it becomes. That's what I've shown there. So I'm going to sub that in. We've got x sine x here. And the negative is going to distribute, so we're going to have take cos x as well. And we're going from 1 to 2 pi. All right, so it's quite a long sort of thing. I'm going to fence that off from the rest of it. And let's go ahead and apply the fundamental theorem of calculus. So we're going to have 2 pi squared. All right, don't forget that squared is going to apply to both of those. On 2 plus sine of 2 pi. Take 2 pi, sine 2 pi. And then take cos 2 pi. So that's when we sub the upper boundary into it. And then we've got to subtract away from that the lower boundary, which is when we sub 1 in. We're going to have half plus sine 1, take 1 times sine 1. So that's going to be take sine of 1 as well. And then take cos of 1. All right, now we've just got to collect like terms along here, don't we? So now firstly, if we're looking along the top here, we've got sine of 2 pi. We know that's 0. And here we've got 2 pi times 0. So that's going to cancel. We've got sine of 1 and then take sine of 1. So they're going to cancel. So already we can start to tidy it up a fair bit. All right, so out the front here, I'm going to have 4 pi squared on 2. So I'll write that out like that. We've got take away 2 pi. We have take away cos of 2 pi, so that's going to be take away 1. Then we have take away half. We have take away negative 1, so that's going to be plus 1. And then we have take away negative cos 1, which becomes plus cos of 1. All right, and then just to simplify our answer, 4 pi squared on 2 becomes 2 pi squared. Take 2 pi. Now we've got minus 1 and plus 1 will cancel. We have minus half and then plus cos of 1. And that is our answer in exact form. All right, so if you chuck this into your run mate in your calculator, if I go 2 pi squared, take 2 pi, take a half, and then plus cos of 1, it's going to evaluate to that 13.49. Excellent. All right, so process we've seen before. Remember, it's always the top function, take the bottom function over a given interval. Yeah, good luck.